In today's video, we'll be solving question in electric field, and the question is asking us to find the electric field, a distance z above the midpoint of a straight line segment of length 2l. So keep in mind of this length 2l and midpoint as well, midpoint. So this is the length. Let's assume this is the length. So the distance from here to this point is 2l, right? And let's assume here is the midpoint, and we're asked to find the electric field Z, at the distance Z above the midpoint. Let's assume this the distance Z, and here is the point where the test charge is. So this is what we have. So the distance from here to here is L, and the distance from this point, the midpoint to this point as well, is L. So but this side is in positive x-axis and this side is in negative x-axis. So let's solve. To solve this, we have to resolve this expression in both y, that is the vertical and horizontal component. This is EY, and starting from this point as well, this is EY. So from this point where the test charge is, right? Sorry, this is EY, and I think I need to clean this part and use the red color for the x component EY. So using the red for the horizontal component, this is EX, and this point is EX. So from this you can see that the EX and EX, they are symmetric. So resolving it in resolving the electric field in the horizontal component is equal to 0. But in this side, the y component, they are not really symmetric. So let's solve. Assuming this hypotenuse is r and this part, okay, is x, right? So resolving this to EX, so now the total electric field should be like EX cos theta, sorry, EX sin theta. This is the theta, which is opposite over hypotenuse, and plus EY cos theta. But we already know that this part is 0, so we are left with the total electric field should be EY cos theta, right? But bear in mind that this expression we wrote here only signifies for this point. Let me use the blue color to indicate. It only signifies this point. Like here, the distance, this triangle, only this triangle. So, and for us to like have the full triangle, that means we need to like consider this part of the right triangle, this right angle triangle, and this other left angle triangle in the negative x-axis. So in that case, but this is actually an isosceles triangle. So in that case, we can say that the total electric field total electric field should be equal to 2, which is 2 EY cos theta, which is 2 in the sense that you have this triangle and another triangle, which they are equal. Since we've gotten the total electric field to be this, right, now the question is, what is the electric field itself? The formula, we have that E is equal to KQ over R squared, right? And we know that Q is equal to 1 over 4 pi epsilon naught, right? So, and sorry, I forgot the R hat. So this R hat is the unit vector. But in this case, we'll be solving the electric field using integration instead. So now we have like the E is equal to the integral, okay, integral of dq over R squared. But remember, the Q is the same thing as lambda dx, right? So R as well, from the triangle we can say that this is the triangle, here is R. So, and using the Pythagoras theorem, we can say that R is same thing as the square root of z squared plus x squared, right? So let's go back to R is the square root of x squared plus z squared, right? So, and using that same triangle, we can find cos theta. Cos theta is which is adjacent. Cos theta is adjacent, which is adjacent over hypotenuse, which is z divided by the square root of x squared plus z squared. So we can say that cos theta is equal to z divided by the square root of x squared plus z squared. So substituting all this back to this equation, we can say that our total electric field will be E K integral, okay, there is 2 here, not forgetting the 2, then EY, which is the integral of the electric field, which is dq. Now dq is now lambda dx, lambda dx divided by, we have this to be r squared. Okay, let me take it bit by bit. And this is the square root of, but in real sense, the square here will cancel the square root, so I'll be having x squared plus z squared multiplied by the cos theta is z divided by x squared plus z squared, the square root of x squared plus z squared. But remember, we are actually integrating, right? So in this case, from this triangle, we move from z. This is the midpoint, which is 0, right? Moving from the positive to the, moving from 0, which is the midpoint, to the positive, it's actually L. The distance from here to this point is L, and distance from here to this point is as well L, right? So in this case, we will be integrating from 0 to L. So our limit of integration will be from 0 to L. So now let's simplify it. Let's simplify this expression. And solve for electric field. Okay, to simplify further, we can take out constants. Then this will be equal to E, which is the electric field, is equal to 2kz, then lambda, and an integral of from 0 to L. Then this should be 1 plus half, making it, this is the x divided by 1 plus half, that should be 3 over 2, and this is equal to x squared plus z squared 3 divided by 2. Now it's time for us to integrate this expression. Okay, but before we move further, I would want to explain something. In this case, remember, we say that E total is equal to 2 EY cos theta, right? So because we considered first angle, this 2 is because we have the two angles, right? That's why we considered only one angle, and since they are symmetric, since they are isosceles triangle, we believe that they are the same. That's why we are writing these two. So, but in the case where you don't want to write these two, that means you consider the entire triangle, and your limit of integration will not be from 0 to L, and you will not be writing these two. Your limit of integration, remember, this is a midpoint. Here is the positive L axis, and this is negative L axis. So your limit of integration will be from minus L to L. So, but we considered half of the angle and decide to work with that. So let's solve further. To integrate this, let's consider this integration. I have this from 0 to L dx divided by x squared plus z squared 3 over 2. So for us to integrate this, we can make some assumption and say let x, or let x be equal to z tan theta. If we assume this x to be z times theta, then that means the x will be equal to z, integration of tan theta will be the sec squared theta d theta. So substituting this expression in the integration, we have this to be integral from 0 to L, then dx is z sec squared theta d theta, and x here should be z squared tan squared theta plus z squared 3/2. So in this case, we can decide to factor out z. Let's take z outside. Then this is equal to the integral 0 to L z sec squared theta d theta, and if we decide to take out z, that means z, this is z squared and power 3/2 into tan theta plus 1, 3 divided by 2. Let's still do a little simplification. This will be z power 3 here, and we have 1z, so we'll be having 1 divided by z squared integral from 0 to L sec squared theta d theta divided by, but from our trigonometric rule, we know that sine squared theta plus cos squared theta is equal to 1, right? And if we decide to divide both sides by cos theta, then that means this is cos squared theta, here is cos squared theta, and this is cos squared theta, then this will be tan squared theta, and here is 1 is equal to 1 divided by this will be sec squared theta. So in this case, we can substitute sec squared theta back to this expression. Then we have sec squared theta 3 divided by 2. So we decide to simplify further again before we integrate. So we have 1 divided by z squared, then integral from 0 to L. Then this, okay, let me take it bit by bit. Sec squared theta d theta divided by, this will be sec cube theta, right? I can now cancel, then I'll be having this to be equal to 1 over z squared, the integral from 0 to L, 1, that is the theta, divided by sec theta. So, but we all know that sec theta is 1 divided by theta. So in this case, this will be equal to 1 over z squared integral 0 to L cos theta d theta. So when we integrate this, if we integrate this using this limit or range, then I'll be having 1 over z squared. Integration of cos theta is sine theta, right? From 0 to L. But remember, we are from our triangle. Let's go back to the triangle. Let's go back to the triangle. From this triangle, we can say that sine theta is equal to sine theta is opposite, which is opposite of a hypotenuse, that is x sine theta is equal to x divided by r, which is same thing as x divided by the square root of x squared plus z squared. So if we decide to substitute this in place of sine theta in the expression, we'll be having one over z squared. Sine theta, we saw it to be x divided by the square root of x plus z, x squared plus z squared. So within the limit of 0 to L. So when we substitute this, we'll be having this to be equal to 1 divided by z squared x now will be L, the square root of L squared plus z squared. Remember, what we got is just the part of the integration. This is what we have before we started integrating. We have this expression, this very expression. So, and it's actually this integration part, that's what we got. So substituting it back, we can now find our electric field. So what we have there is that E total, which is the electric field, is something as 2 kz lambda, then integral from 0 to L dx divided by x squared plus z squared 3 divided by 2. But we've gotten this integration to be this expression. So if we decide to substitute, we can say that our electric field will be equal to 2k z lambda, then multiplied by 1 over z squared multiplied by L divided by the square root of L squared plus z squared. So z can cancel out, right? So, and this is equal to, okay, let me do some rearrangement, and this is equal to k lambda 2L, right, divided by z into squared plus z squared. So this is our electric field, although we can introduce k, because we know that k is equal to 1 divided by 4 by epsilon naught. So if we introduce that, we can say that this is equal to 1 over 4 by epsilon naught multiplied by 2L lambda divided by z into L squared plus z squared. Sorry, I omitted my square root here. There should be the square root as well. So in this case, this is our electric field. Thank you for watching this video. If you have any question about this video, feel free to email us at science-elearning@gmail.com or nesalifa academia@gmail.com.